right, okay, I think we get started. Lovely to see you, everyone. So, as the title suggests, this is about local language models, and then kind of the why, what, and how, because I think these are the three most important questions that will show up when you are looking at like local LLMs. So, brief outline, we will touch on, these three questions, and then, some of the points that we will touch on. The why is going to be very brief, and then the what, I will just give some of the considerations that, these are the stuff that you should think about when you want to run local. And then the how is more the tutorial section. Full disclaimer, this whole thing is going to be super opinionated. So this is not best practice, not anything. This is how I do it. I spent a disproportionate amount of time learning about this, so I think I have a pretty okay opinion. But this is by no means like best practice or anything. It's just like how I do it. So full disclaimer. Cool. So why are we running language models locally? So the number one, I guess, is privacy, right? Is that if you have sensitive data or from a company or from, I don't know, some people upload their journal notes to a language model and then use them as therapists, which I find absolutely terrifying behavior. But like people just do that, right? And then I have 2 pages of a rant about my anxiety and I just give it to Sam Altman in a country without any data protection. It's like, no thanks. So I think the privacy part is pretty big. And even if you only use it for work purposes, like for me, I can just take schemas from a company database or proprietary code or an interview that is really, really, really not public and then just feed it through a local language model because I know that, I wipe the RAM and then the whole thing's gone. So it doesn't go out of the machine, right? So the local first, good stuff. Yes, so I think that's about the privacy. Should cover it. Efficiency. So local hosting is free. Yay, we like free stuff. Yeah, of course, like compute cost and hardware amortization, and it's like how long will your laptop last if you constantly blast language models on it. I kind of want to avoid that part of the conversation because I want to focus on stuff that you can reasonably run on your current laptop without having to rent a bunch of GPUs and an AWS cluster and nonsense like that. This is like local. So that is free, which is nice because as far as I know, neither of the unis reimburse your Claude or GPT subscription. At least they didn't do it for mine. You can pick the size of the models for the task, which I think like now, with GPT-4o mini, it started to kind of proliferate a touch that like, yeah, there is a big model which is slow but smart, and there's a small model which is like dumber but quicker. But I feel like that duality is like either you do the big behemoth with 700 billion parameters, or you run the tiny little baby, which is still, I think like a good 200 or something like that. It's still very big. You just have a much bigger range, right? So if you need something to run on edge devices, then you can just pick a very tiny model. If you need something to be really quick, really smart, and you have a big cluster, you can just pick that. So if you run local models and kind of detach yourself from the big providers, you just have a lot more freedom in kind of picking the model for the job. And then the customization part. This will start getting into the nerd shit. Later, I have a slide on like nerd shit, but like the customization it goes a long way. And I know that like if you use the API playground for OpenAI, then you can still tune your temperature and your blah, 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 blah. But like it still doesn't get anywhere close to what you can do with the local model. The amount of customization that you can put through this is absolutely insane. It makes a huge difference in kind of achieving the task, right? So these are kind of the efficiency part of the why. And then the ethics slide. Now, I don't want to spend too much time on this. These are, I don't want to tell you what to think. These are just the considerations. Whether you like the people that proliferate these big language models and the whole game that they are playing now. I promise, bro, AGI is next year. I promise, bro. It's like the year of Linux desktop. It's next year, bro. I promise. I have grown extremely bitter about the whole big AI, big tech firms and the people around it. So for me, like not supporting them was pretty high up on the priority list. Amazonian forest, you ask 3 questions about your code ChatGPT and you're done 2 liters of drinking water and the ice cap melted by a kilo. Nuclear reactor data centers, it's like, are we actually sure that this is the best way forward? And then of course, like the good old theft, right? Like IP questions and how it was trained and, what's up with copyright and all of these. Because if you want to, with open source models, you can just pick models that disclose their training data, and they disclose that, hey, we did not steal anything, which should be pretty much the baseline, but it very much isn't. These are kind of the ethics considerations. You make up your own minds. It's also like no one has to care about this. You can pick and choose. But this should cover kind of the why you would want to do the local language models. If there is any question, I'm very happy to answer it now, but we can also do it at the end of it, so cool. Okay, now, what can you run locally? Because I keep saying local and open source language models, but this is a bit ambiguous. I think it's important to see kind of like where this started and how this started. So how it started is that somebody pushed the Llama 1 weights in a Git commit, and somebody on 4chan noticed it. So this is how it started. This is a Verge article in 2023 March, when somebody spotted that from Meta, a researcher accidentally pushed the entire weights of the first Llama in a Git commit. And then somebody fished it out, and then once something is on the internet, it never leaves. And it was a huge deal, and that was very funny to see like everyone freak out, like, oh my god, this is such an existential threat to society, oh my god, we are gonna all die. And then Llama did the only PR compatible move that they could. They were like, oh bro, we wanted to open source it all along. Oh, trust me bro, it would have been open source a week later. So ever since that, the Facebook or like the Meta AI lab is famous for open sourcing all their stuff. It's actually not open source, it's a permissive free use license, so it's not an actual MIT open source. For all intents and purposes, it's open, right? You can download the weights, you can play with it. So Meta got on the game of just pushing everything open source. But since then, a lot of companies kind of jumped on this with actual proper MIT open source licenses. So basically, you have a huge community, a lot of AI labs from very small to Meta sized, who are publishing models and weights and different versions of models, different fine-tunes of models, and an insane amount of options on the market, like really thousands of different models. So if you think that like Hugging Face, basically like Hugging Face just has separate sections, right, where you can just like look at any fine-tunes of models, versions of models. The whole thing is amazing, and there is constantly new things rolling out. So if you are very much online and spend a lot of time on forums, like myself, then like there are like, oh my god, somebody fished out the model weights for 5.4 from the like Microsoft Azure playground, and then they made it available to Hugging Face, and you had to wait 3 more weeks to get it from Microsoft, but this guy fished it out, and now you can play with it. The whole thing is just super like high-paced and super interesting, and constantly new developments are rolling out. So I think it's a very cool place to like hang out at if you like the tech behind it. Now, what do you need to consider when you want to run a local language model? Like obviously you have model size. How many parameters does it have, right? Like when this is the little number b, like we are measuring it in billions of parameters, no news there, and kind of like how smart a model is inversely proportional to speed, just like humans. So if you have a very big model, it might be really smart, however you define smart. I don't want to get into that, but it's going to be slow as hell. Or you can have a smaller model, which is going to be lightning fast, but obviously somewhat limited in capability. The other important piece is context length, kind of how much a model can like process. And I think a lot of people forget that context length is also about the length of the memory in a conversation. So you might be like, well, I don't need long context length because I only do like little chat stuff. But if you try to interact with the model with a really small context length, it's a really, really frustrating experience because it keeps forgetting what you tell it. Because the way these work is when you send a new message, it just loads the entire previous conversation into the context and then like next token prediction afterwards. So very short context, very short memory, super annoying to work with. This is the opinionated part. I much prefer a smaller model with a much larger context length than the other way around, because it's just so annoying to deal with. Yes?
Is Gemini has the largest context?
I actually know nothing about the Google models. Gemini is the one that I have not played with at all. I know that Claude 3.5 Sonnet had the longest one for a good while, because it was like 300,000 tokens, I think, or something like that. I know that 128,000 token context length is like fairly common now. That is also not something that you will be able to learn locally. Like the amount of ROM you would need to load in 128,000 tokens is batshit crazy. I will show you.
1 million.
1 million tokens, yeah, that's
2.0.
yeah, that's really long. I also think that that becomes useful if you want to do like super big, like retrieval augmented generation, like huge RAG use cases.
Yeah. But just a simple question. So in this case, you can have conversations for a long time with Gemini on the same topic, and it will not forget.
Yes, yeah. So the super long context length is like you can just keep having the same conversation. If you said something 2 weeks ago,
Yeah.
it will probably still fit into 1 million tokens. So as long, because it basically just has 1 million rolling window of, and then if you type in and it outputs you, because like it also counts the output tokens, right? So.
Yeah. So I was wondering, as you said, the entire previous conversation is like inputted as well when you're asking a question. Is this also why, or does it happen that if you have a long conversation, that the inference time gets longer as well? Because
yes.
Okay. So
Yeah, absolutely. Also, my favorite thing, which you might have seen in like memes, is that if a language model gives you some code, and then you just tell it, do better, or you can even just type bro ? If the code is shit, it will generate a better output. And like, this is why, it's not getting bullied, but it just does another pass of its own output and understands that it needs to improve it, right? So this is why the iterative improvements happen when you just bully the language model. It's like, hey, do it better, do it better, do it better. You just basically give it multiple inputs on the same thing, and it does multiple passes over it. But yeah, this is why inference time grows. And this is also why reasoning models are so incredibly expensive to run, is because every user-facing output needs to go through a bunch of like thinking, and then every new one processes the output and the thinking behind it. Massive, massive, massive context windows. So context length? Yes, any good, amazing questions. I'm grateful. So if you let me know if you have any other ones, because it's interesting.
Are you going to go into the max contents that you yourself play with?
Yes, I will show all full stack. I will show all the good stuff. So, okay, and quantization. This is kind of the main trick of local language models, and this is basically kind of like how compressed the model is. And it's not the same as so because if you compress a file, then you are basically trading file size for compute to process it, right? This is the trade-off in compressing a file. Because if an uncompressed file is very easy and quick to process, but huge, whereas a compressed file takes up less space, but takes more compute resources to process, right? You are probably not video nerds. This is why H.265 is nicer than H.264, because it's more efficiently compressed, whatever. But quantization is very big, and I think I have a slide on it. No, I do have a slide on it. I will come back to quantization in the second half. So about the compute, kind of, because this is all well and good, but what about the compute, right? The two bottlenecks. So you will have like RAM or VRAM restrictions, because in order to do inference on one of these models, you need to load the entire model into your RAM, or if you are running it on a GPU, then your GPU's VRAM. There are a bunch of frameworks that enable you to kind of like tie VRAM into your normal RAM. So if you have a video card with 8 gigs and 32 on your normal machine, then it can do some clever swapping that is still quicker than running it from, disk IO, which will just not work. But in principle, how much RAM you have will determine how big a model can you run. My rule of thumb is you can run as many billions of parameters, as many gigabytes of RAMs you have. Rough ballpark. And when I say rough, it's like rough. Because, for example, it will depend on the quantization, blah, 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 blah. But like in principle, this is a good rule of thumb. So if you have a machine with 16 gigs of RAM, then I am happily running a 14 billion parameter model on it. Great inference speed, the whole thing is kind of nice. Whereas on this machine, my company MacBook, which is a beautiful spec'd out 32 gigs of RAM, on this one I can run 32 billion parameters without much of a trouble. So this is the rough rule of thumb, is as many gigabytes of RAM, that many billions of parameters. So we are not looking at hundreds of billions of parameters unless you have a server underneath you. And then the CPU, GPU, that's going to be the inference speed. So if you don't have a GPU, but you have a bunch of RAM, you can just load in a big-ass language model and then wait until the sun goes cold for the little CPU to sequentially do all of your little operations on it. It will be possible. It's also not like that. I'm just being dramatic here, obviously, but like it's quite slow. So if you don't have a GPU at all, but integrated GPUs in a laptop already go like a really long way in speeding this up. So the real restriction here is the RAM. And then the GPU is like a quality of life, right? If you want lightning fast responses, then obviously get a GPU. Yes, so that's the heuristic, right? Is that if you have a very big model, so a lot of RAM, but no GPU, very great answers, but very slowly. So this is kind of how you can think about this. So based on this, you can already start kind of like gauging what model size you are able to run on your own machine, right? Because if you have 16 gigs of RAM, which I assume they went over laptops are running on 16 gigs of RAM or 32.
We updated after the blue screen. Now we got how many?
I think we have 32.
Yeah, 32.
Nice.
Yeah.
Hell yeah. Okay, again, full disclosure, I've never tried any of this on Windows. So like, I know Ollama is, which I will show, the tool that I use to run all of this shit. It's completely platform agnostic, so it will run on Windows too. I do not know whether a 32 billion model is a good idea on a Windows machine, just based on how efficient Windows is in managing your memory. So.
It's WSL for Windows.
Oh yeah, that's true. Okay, yeah. So you can do a WSL, and then that might be more efficient in doing all of this. Cool. Model selection, yay. So which model to run out of the 100 million that is out there? So the right tool for the job, right? So how I got into doing this was I wanted to run Positron, the amazing new generation data science IDE from the people that made RStudio. And they decided, like they realized that RStudio is terrible bloatware, and then they rebuilt an IDE which does the same as RStudio, but based on VS Code. It's based on the VS Codium, the open source version of VS Code. And it is great, I love them, it's an amazing project, but it does not have GitHub Copilot. And then I was like, well, that's annoying, because I don't like renaming variables by hand. So I started digging around like, okay, I talked to an engineer, a friend of mine, and then he said like, I'm running like a local code completion. I was like, local code completion. I have the compute on the machine, so I can push it. And that's when I got into it. Like I wanted code completion in an editor that didn't have GitHub Copilot. And these are called like fill in the middle, like kind of code models. And then basically what they do is they look at what is like, in front of, like previous to your cursor, what is after your cursor, and then try to guess what the next token of code would be. These very much vary in quality. So GitHub Copilot runs a huge model with an ungodly amount of compute underneath. So most of the open source ones will not be that nice, but this is how I got into it. But based on this, you can already kind of tell that like these have very different, like you cannot just like chat with them. Or like, I tried, it's just a pretty shit experience because like you send a message and then they will suggest like, I don't know, some weird TypeScript code for it, and it's like, I don't know. So, but they are very different, right? Whereas if you want to have a conversation model, then you will look at different ones. If you want to use it for vision or any kind of multimodal processing, video or audio or whatever, these all have different needs. So you kind of need to look around and find which model is good for the stuff you want to do with it. I will give recommendations on all the stuff and which models, super opinionated once again at the end, but like this is the consideration. It's like you will need to play around a bit. And also the right model for the job, you need to decide whether you like the model, like in the personality that the model has, like huge apostrophes, because I'm not a huge fan of anthropomorphizing these, but some models just give very annoying answers. Like I like the Quen models from Alibaba, they are super powerful, but I just cannot stand the style in which they reply. So either I don't run them, or I run them with the biggest system prompt where I just bully them until they give responses that I like. So that also works, but these models have different flavors. Like if you use Claude and ChatGPT, they are distinctly different in how they respond. So this is just a consideration that you also need to like what you're working with, right? And yes, what your priorities are. So I have different model configurations for different stuff. So if I want to do retrieval augmented generation on all of my notes in my PhD, then I will have a tiny model because it just needs to summarize. You'd need like, I don't know, 3 billion parameters for that, but a big ass context window so I can jam it full of stuff. Whereas if I want to edit my manuscript and hey, here is a clunky ass theory section, help me rewrite it to sound better, then I will use a bigger model, more capable, with a smaller context window. Because I will just keep pasting in my current version and ask for multiple passes on it. And then it works well for me. So kind of this is like the meta principles of like considering what you want to do with the model and like what would suit that best. Quantization, yes. So I mentioned that this is kind of the magic that got us like very, very powerful models local. It's basically the precision at which parameters are stored. So F16, it's not full, it's half precision. So basically every float is stored as 16 bits. This is kind of like the full precision as you would be looking at. It's called half precision, but this is the highest that you use in computer science, unless you have a reason to not do so, but like this is fairly standard. Q8, so quantized to 8-bit. This means that you cut off the last 8 digits. And it sounds so stupid because you literally just do that, like you just truncate digits from it, but you can cut the model size immensely without like any big impacts on performance. And once people figured this out, all models started shrinking at insane speeds because all of a sudden you can just take a big model, 70 billion parameters, quantize it down to, I don't know, Q4, which is 4-bit floats, which is usually the standard. So if you just go for a llama, it will give you a Q4 quantization, which is about half the size of an F16, which is mad because all of a sudden a model goes from 50 gigs that you cannot run on a 32 gig machine to 25 gigs, which runs no problem. And then you will take a hit in performance, a slight hit. I don't think I have a slide on like kind of what the different like effects of it are. In principle, if you have the memory for it, Q8 will perform like feeling-wise better than Q4. Don't bother with F16. I am yet to find a use case where the 16-bit precision like actually matters.
So I have 2 questions.
Yes.
A few slides back, you gave some kind of rule of thumb for like this is how much RAM you have, and you have this size model.
Yeah.
Is that taking into consideration that it has been quantized?
It's Q4. That's the ballpark for Q4.
Okay.
Yeah. I'll show you some numbers in the demo part. So.
Okay. Okay, but that's good to know. And then.
All right, then we are just going dark. That's okay. Oh, this is gonna do wonders for the video quality. That's okay.
So, because would you say, in your opinion, it is better to the models that are first larger and then quantized down are better than models that are not quantized down but have then the same effective size?
So in gigabytes. So
yeah, in like
okay.
So let's say like I have 8 gigabytes model which is half precision, and I have a 16 gig model, but it has been quantized to 8 gigs.
Oh, yeah.
Which one would you say? Okay, first try this one.
Yeah. It's a preference question, actually.
Okay.
My experience is that bigger models quantized down are better. They will just be more capable. That's just my experience roughly. But for some use cases, like, I don't know, I played with some models which were like multi-model, taking in vision stuff, and like a big model that is general, quantized down versus a small model which is more specialized, like at a Q8 or something, usually performs better. But there are absolutely no hard rules here. So my preference is I optimize for speed. So what is the speed of inference that I can tolerate? So for example, I can run 32 billion, but I just basically never do because, I don't know, DeepSeek thinks for 4 minutes before giving me a training loop for a PyTorch model, right? So it's a bit too much. Whereas I'm very happy with a high precision 14 billion 5.4. So you have to try out a few things, see what you like, right? And then if you find a model that is pretty big but quantized down still gets the job done for you, great. But it's a lot of moving parts in this, right? Because you have basically your parameter size, your precision, and your compute, and then you're tuning all of these. Or for example, like when I crashed my computer like this once because I was doing some pretty heavy data frame operations in Pandas. And then I asked DeepSeek for something, and then DeepSeek was like, okay, I will take 28 gigabytes of your 32 gigs of RAM. And then it just straight up crashed my Python kernel because it was just like run out of memory. Yeah. So, you know, if you want to do something besides it, or if you are one of those people who have like 1,000 tabs open in your browser, then maybe very big models are not going to be your friend. I don't do that, so, you know, but it's going to be a tryout question.
Clear.
Oh. That's light. Can you try it again, Naomi? Yay! Nice. Easy. First try. Cool. Yeah, and Q4 is the Ollama default. So if you just pull a model name from Ollama, it's going to be Q4, because Q4 is pretty good. Opinioned primer and models. What do you want to run? These are also links. I will send these slides out to everyone afterwards, so don't worry about it. So my daily driver, I run a 5.4 at Q8. So 5.4, Phi is a Microsoft initiative of training SLMs. So this is the small language models instead of large language models. And then the whole Phi initiative was, hey, how about instead of doing grand scale larceny on intellectual property, we just buy a bunch of textbooks, curate our data very, very precisely, and get really smart about training, and then just train small models like that. And then Microsoft started doing this. I've been following them since Phi 2, which was already pretty cool. And then Phi 3 and 3.5 were already very cool. And then Phi 4 came out last December. And that's super cool. That is my daily driver period. It's a little bit annoying because you can tell that Microsoft like censors it very heavily in terms of like how the disclaimers it gives in answers and all of this. But a good system prompt can break its hand in that quite well, and then like you force it to give short answers and blah 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 blah. So you can dial that in for your taste. But my daily driver is that, like that's the default model that I run, and that is about, because I have a pretty big context window, it takes up about like 20 gigs of RAM, which is fairly doable. That means that you can still do stuff besides it, which is nice. Small model, Phi 3.5. It's a 3.8 billion parameter model, which is tiny. It's like 4.5 gigabytes at Q4. Runs really, really fast, and it has a context window of 128K maximum, which you will not be able to run because that is way too much to store. But in principle, like that's what I use for RAG use cases. I will have a demo on RAG later, but that's really, really good because it summarizes stuff very well. It can do like very basic like reasoning and some like pick what's useful for you and stuff like this. Runner-up small model Llama 3.2. That's a 3.1 billion parameter model, I think. So it's also very small, 4 or 5 gigs. That runs on your phone. So like these two you can run on I think I tried it on an iPhone 15, and then you could just run it. So that's pretty cool. Code completion, Qwen 2.5 Coder and Star Coder 2 both are pretty good options. Again, keep in mind running local. Here, I wouldn't try bigger ones because they have like Coder at like, I don't know, 7 billion parameters, but it's just going to be so slow that it's not good for code completion. So that's just something to keep in mind. Yes. Any questions? This doesn't say a lot to you now, but when you click all the links, it will take you to places and then it will make sense, hopefully. Okay, now the juicy stuff. How do you actually do this? And this is the part where like, I know there are a million ways to do this. This is how I do it. You know, take it or leave it, roughly. This is the one I can help you with. So tooling, Ollama. It's the best tool I have found to like run and manage local language models. It has a repository, so you just look up something, you install it on your computer, I will show you, and then you just go Ollama pool, and then the model name, and then it just downloads the model for you, stores it on your disk, and then if you want to run it, it's just like, it just runs. So it's super simple, offers a bunch of different quantizations, you can customize all kinds of stuff about the models, really good tool, love it. Open Web UI. Because Ollama handles the backend, right? The actual download model, run the model, compute the little matrices. But you need like an interface, right? And like you can use Ollama in the command line. It's a shit experience. I would not recommend. Open Web UI, open source, interface entirely built to interact with local language models. And if you have Ollama installed, you just shoot up an Open Web UI instance and it will detect Ollama in the background. You have to do nothing for it. It just immediately download it and then it just runs. 10 out of 10. So I highly recommend this, and I will show you exactly how you can set it up. So instructions, this is what you can follow at home. And then download an appropriate model. So install Ollama. I don't have a link, you will find it. Windows, Mac, Linux, whatever. WSL, consider that. Maybe that's gonna do better than a Linux, like a Windows AI itself. And then you just run Ollama pull, and then a model name. It's gonna download the Q4 quantized version. Yeah, at that point, Ollama will be running, of course, and then set up Open Web UI. I will push UV until the day I die, because UV is the best tool for managing your Python projects and dependencies and everything. It does everything that pip and venv want to do, but much better. It's lightning fast, it's written in Rust, amazing people behind it, 10 out of 10, just go with UV. And why I'm plugging it specifically here is because if you see UVX, that's how the command starts, it will install it in a temporary environment. So you don't install it into your root Python. You don't like contaminate every package, every environment that you use, none of that. It will create a separate Python environment using Python 3.11 and will install Open Web UI in it and then run it for you. It's the cleaner, it's a zero commitment version of running this. Because you just run it, it will shoot up a server, you can interact with it, you can kill it, and the environment's gone. Super clean. So, you know, I think that's the best way to do it. And then localhost 8080 is the place, because it's, you know, local, and that's what we are doing with it. I think I have yeah, so it has, you know, why would you do this? Chat interface, I'll show you in a second. And you can do reg with it. And it handles a lot of the annoying backend involved in doing reg. So it's pretty cool. Reg demo, yes, okay. I put this in here so you can set it up on your own, but I will show you kind of what I have here. And then a pro tip, mark it down. This is a utility that Microsoft released, which takes any Office document, be it Excel sheets, presentations, PDFs, Word documents, and turns it into plain Markdown. Mind-blowing how good it is. It does better than anything out there that I tried. Apache Tika comes pretty close. And Apache Tika runs on a few, like, I don't know, if it's not docx, but just doc, then this doesn't do that, blah, 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 whatever, don't care about this. If you have a Word document and you don't want to, you know, mess around with it, you can just run Markdown on it, and then it will spit out a Markdown document, which you can just feed into any language model. Really cool. If you have UV, same idea, UVX, temporary environment, Markdown, example, and doc, and then it will just spit out a Markdown file without having to install Markdown or without having to do any of that. So super clean. I will check if I have Ollama running. I do not, nice. So Ollama, you just start it like that, and then now you have a little llama in the corner. That's it. So Open Web UI sets up, you have to specify like a data directory for it, which is there to kind of make all your information persistent and settings and previous chats and blah, 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 blah. On their website, they have a very nice tutorial. I'm also super happy to share whatever about it, so I will help out. Open web UI, yes, and then you see that application running on 8080, so we can just go here, log in, and then there are new updates all the time, of course, and then this is it. So this is, we are here. You can see the models that you have running locally. I don't know, here is the big DeepSeek. You can see that it's 18.5. Can you see the font size? I will increase the touch. Yeah, so you can see that, you know, this 32 billion parameters, 18.5 gigabyte model size. Here is my dear 5.4, which is default at 14.5 gigs. 3.5 mini, 3.8 gigabytes, blah, blah, blah. So yeah, and then here you can do all the same things. It's like, I don't know, why should I run LLMs locally? And then this is gonna be, oh yeah, Ollama needs to kind of like wake up a bit and start a server in the background. But you see, this is the live inference speed of, and this is all on the laptop, right? So without any hassle involved. Yeah, so this is fairly cool in my opinion. And like, it also gives you a little nerd data if you're interested. Tokens per second, prompt, duration, blah, blah, blah. So it gives you all the nonsense about like how quick something is working. If you want to diagnose stuff or try stuff, it has all of that. If you look at the terminal, this was like this whole stack of interactions. Is that like, hey, I sent that was unauthorized, and then I sent a request and whatever on back and forth. I wanted to show the retrieval augmented generation because I think that could be pretty interesting. So I created a little example markdown. Yeah, so this is in there. Can you say this? Probably not. So now maybe. So this is the content of example.markdown. Best ice cream flavors, best way to run LLMs. Yeah, so this is the entire content. It's like, I don't know, 7 lines of a markdown file. So what you can do here is go to your little workspace and set up a knowledge, and then I will delete this because I tested it out, obviously. But you can just create like, hey, I want to create a new knowledge base, example reg base. What do you want to do? Show off, and then create a knowledge base. And then here you can just add stuff to it, and then, I don't know, upload files. You can upload files or the entire directory. The directory is pretty cool because if you upload a whole directory, there is a button, it's like sync directory, and then it just like makes sure that if you added new files in the meantime, it pulls it up. So I do that with my notes, for example, because if I create new notes, I just click on sync and then it just takes whatever is needed to be run upstairs. Example markdown, and then you can send it in, and then file added, lovely. So now we just have this knowledge base, which has this one example.markdown. And then now we can create, I will also delete this one, create a new model for it. And I am going a bit quick. I know the interface is a bit overwhelming at first, but if you need help with it, I will help you set it out. So new model, okay. You have to specify some example reg phi. What base model do you want to use? Again, I like the small phi, really good. What do you want a description? You can play with the advanced parameters. So this is all the stuff that you can tune in Ollama. Context length is pretty useful to crank up in reg settings. So I don't know, we can do, let's do like, I don't know, 12,000. That's a pretty reasonable one. And I did not connect the knowledge yet. And then here you can attach knowledge and then example reg. And now the model has knowledge. So if I go to new chat and I go to example reg phi and I go, what is the best ice cream flavor? Searching knowledge base. And what it does in the background is, if you check, Ollama PS is the process log of Ollama, so what is running in the background. You see the embed text model. Open source model that makes embeddings of stuff. It's the best tool for reg that you can find. And what it does, why that is running, is because when I uploaded the example markdown, it ran an embedding on it and chucks it into a little vector database, and then the model runs a query on it. And you can see here that this runs 15 gigabytes of memory on it, and let's see whether it knows. According to the list provided, Amarena, cherry, vanilla, and chocolate are considered the best ice cream flavors. And this is the Microsoft, disclaimer. Oh, each person has their favorite. Yeah, I don't care about that. But there is no system prompt in this, so it's going to be nice and polite. What else can I show? Oh yeah, I think I have a few more slides. Oh yeah, maybe on the nerd stuff, I have some. Yeah, so this is maybe the last kind of stuff, and this is only if you actually want to get into it. But some environment variables for Ollama. That is also a link into their FAQ on how to set these. Flash attention to 1. This will dramatically decrease the memory requirements for long context windows. Really nice. And then key value cache type. If you have a context, it will reduce it to key value pairs, because that's just how it handles all of this. And then what precision you store this key value pair cache at affects your memory requirements. Same idea. By default, it does 16-bit. You can truncate it down to Q8, no problem. With Q4, you will notice a hit as the context window grows. So for RAG, I would not truncate it, but for like some standard conversation stuff, perfectly fine to cut it down. For me, the Q8, like across the board, is pretty fine. So even for RAG use cases and whatnot, it works fairly okay. But like Q4 is much smaller, but then you start to run into that, like it's not super precise and stuff. And then there is a blog post link in the slide that you can just check out if you're interested in it. Resources. Read the friendly manual. That's what all of these starts with. If you're familiar with open source, then you will see that a lot. All of these tools have really nice documentations. OpenWebUI, Ollama, all the models. You can also go on like Reddit and people just like benchmark all of these, see what works, see what doesn't. And then I want to plug a guy, Simon Willison, absolute legend. He's probably the best, like most reasonable voice in all of this AI everything. He's been running a blog for like, 20 years on all things coding. And now he's the guy to go to for what can you do with a language model right now. And he doesn't hypothesize about, oh, AGI, bro, I promise. And it's not into like AI safety and how it will ruin the world. He's like, hey, what are the use cases for people that want to do some coding with language models? What can you use it for? What are the ways? What are the new developments? Amazing resource. Yes. Do I have anything else? No. That is it. Thank you very much.